Most plants trust a single number to judge every truckload: weight. It's reliable, legal for trade, and universally understood. But there's a whole layer of measurement most operations never see, where that weight is actually sitting inside the truck body. A truck or platform scale never sees the load itself. It measures force. Load cells convert that force into an electrical signal, and the system outputs one figure: total weight. That number tells you whether the load is acceptable. It does not tell you whether it was loaded well. Because weight is an aggregate measurement, it has no spatial dimension. Different shapes can show all the same reading: an evenly distributed load, a right side heavy load, a front heavy load, or a body that is partially empty with dead space in the corners. On a scale ticket, they all look identical. That blind spot shows up as real cost over time. Uneven load distribution changes how force travels through the vehicle, which accelerates tire wear and component stress. An off-center load shifts the center of gravity, reducing efficiency and increasing fuel burn over repeated haul cycles. And, when payload shape is weak, you leave capacity on the table even while staying under your weight limit. Wingfield Scale Measure built WingScan to close that gap. WingScan is a volumetric LiDAR load scanner that measures geometry instead of just mass, capturing thousands of points across the entire tray surface on every pass. From that scan, the system generates a 3D map of where material actually sits, how high, in what shape, and how it fills the body. Each WingScan image is rendered as a height map, color-coded from the lowest areas to the highest peaks of material. Instead of collapsing the load into one number, the geometry is preserved. That lets you see left versus right splits, front versus rear splits, and exactly how material is distributed across the body from a single payload scan. Loads that pass every weight check can still show more than a 10% lateral imbalance here, and that is not rare. One bad load is an anomaly. A week of bad loads is a pattern. With WingScan, you can spot operators who consistently load off-center, equipment that shows a persistent lean, and fleets that are meeting weight limits while leaving geometric capacity unused. These inefficiencies already exist on most scales-only sites. They've just never had a measurement layer to reveal them. Wingfield has been solving measurement problems since 1937, starting with mechanical scales and growing into a full suite of industrial wing and LiDAR systems. Today, WingScan covers bulk material wherever it moves. WingScan-B for conveyor belts, WingScan-T for open-top haul and highway trucks, and WingScan-R for rail cars. Those systems tie into stockpile inventories and legal for trade truck and rail scales, so operations can trust their numbers from production, through storage, all the way to outbound shipments. Weight will always answer a critical question: did this load meet the limit? Volume answers a different one: was this load shaped well enough to protect equipment, fuel, and capacity? The gap between those two questions is where cost quietly lives, and loads that look fine on paper cycle after cycle while asymmetry builds underneath. If you're ready to see more than a single number on a scale ticket, Wingfield can add that missing layer of measurement to your operation. To learn how WingScan fits into your haul fleet, conveyors, or rail system, connect with Wingfield Scale and Measure or visit wingfieldscale.com.